Greetings and welcome, friends. We've been talking about normal form of a linear equation, page 467. Here's problem 15. They ask us to write the standard form of the equation of a line given p, the length of the normal segment, and phi, the angle that the normal segment makes with the positive x-axis. Now, this is basically all about normal form. Normal form here, by the way, is x times the cosine of phi plus y times the sine of phi. I'm not quite getting my phi's right there. There, that's a little better. Minus p is equal to 0. So the first thing I would do is plug in what I've got. So I'll have x times the cosine of 5 pi over 6 plus y times the sine of 5 pi over 6 minus 2 roots of 3 equals 0. Now, cosine of 5 pi over 6, you might realize is a second quadrant angle. So cosine's negative, and its reference angle, of course, is a singular pi over 6, which is going to be root 3 over 2 in a second. Plus y times sine in the second quadrant's positive, but in terms of its reference angle would be plain old pi over 6, which is 30 degrees, by the way, if you're wondering, for you radian illiterate individuals. So let's see, x times the negative cos, that's negative root 3 over 2 times x, plus sine of pi over 6, or sine of 30 degrees, is a half. Y minus 2 roots of 3 equals 0. And in order to get this into standard form, I've just got to get rid of the fractions and the negative a value. So I'm going to multiply both sides by negative dose, and I'll get root 3x minus y plus 4 roots of 3, because notice that this ends up getting larger in the process. So there we go. That's the general idea. Question?
I converted it to degrees. Is that okay?
I'll give you a frowny face for that right now. But 5 pi over 6 is 150 degrees. The reference angle is 30 degrees.
Yeah.
So that would have been the degree equivalent of those. Here's problem 21. 21 had different directions. It says write each equation in normal form, then find the length of the normal and the angle it makes with the positive x-axis. Now, the value of c here is, let's see, let's actually label things. A is equal to 5, b is equal to 12, and c is equal to positive is really all I care about, c. And what I'm going to do is do my little square root thing. And in this case, the sign of this square root is negative because it's the opposite of c. So I'm going to have the negative of a squared plus b squared, and that's equal to the negative of 25 plus 144, which is equal to negative of, is that 169? You don't say. And that is my favorite number. That's 13. Negative 13, right? And now what do I do with this guy? I divide my entire standard form by it, and that's actually going to convert it into normal form. So I'll have 5x divided by negative 13 plus 12y divided by negative 13 plus 65 divided by negative 13, oh, don't forget, equals 0, technically also divided by negative 13. So let's simplify this a little bit. So this is negative 5/13 x minus, I suppose, 12/13 y minus 5? Oh, I was wondering if they went in. Looks like. So what we can gather from this now. So this is technically right here, this is normal form. All right. Now, if you wanted, you could multiply all through by negative 1 just to get rid of the negatives if you really wanted, but you don't have to. That would give you a negative p value, I believe. So it turns out that cosine of phi is equal to negative 5/13, right? And it's also true that sine of phi is equal to negative 12/13. So based on that, what quadrant am I in? They're both negative, so I've got to be in quadrant 3, right, is what I'm talking about for the location of my normal. So somewhere in quadrant 3. All right, so I know that. So I'm going to cos inverse both sides. or you could work with the sign if you wanted, it doesn't matter. And phi is going to equal, well, cosine's negative in this quadrant, negative of cos inverse of plain old 5/13, because I want to kind of work with the quadrant 1 so I don't mess up. Cosine inverse of 5/13 is, oh, am I in radians over here? There we go. 67. Phi is about, wait a minute. Sorry, this minus sign, I don't want that minus sign there. Yep, my bad. So phi is about 67.3801, or more specifically, the reference angle for phi. Okay? So that's my reference angle right here. How do I find the actual angle phi? Yeah, I guess technically this is also the reference angle here, isn't it?
You always add 180? No.
It depends on which quadrant it's in. So yeah, 180 plus a reference angle would give me my original in quadrant 3. In second quadrant, you subtract it from 180. In third quadrant, you subtract it from 360. Yeah. So 180 plus that guy. I'm not trusting any of my math today. 67.3801. Yeah, 247.3801 degrees. And the value of little old p is equal to positive 5 because it's the opposite of the value in the equation itself. So what is this referring to? Here we are. Let's say this is my angle, which it's actually less than that, and this distance is 5 units. Then that means this point is the end point of the normal, of which if I drew a perpendicular line to that, that would be the line that I'm describing, and this is perpendicular to my normal. That's what I'm talking about. All right, so thanks for watching, Internet friends. Have a great day. Bye-bye.